Hello grade 11th and welcome to this Junior Techie Summer School, the physical science section of the summer school with me, Natasha Barton. And in this video we're going to be taking a look at question number 1, or at least the first part of question number 1. I've broken up question number 1, which deals with Newton's laws, into three separate videos in order to keep the videos short. Now what you're going to notice is that this question number 1 is not like the question number 1 that you're used to. We normally start off papers with multiple choice. But this paper is unlike the papers that you're used to. Instead of taking a past paper, I've combined a whole lot of longer questions from a variety of past papers in order to help you prepare for your November exams. So unfortunately, we are skipping the multiple choice section, which is actually a very important topic or section to study while you are preparing for your exams. So please do go over that section using other past papers, but for now we are jumping straight into the longer questions. So this question number 1 deals with Newton's laws, as I've mentioned, and I would like to recommend that with all of these videos you start off by attempting the questions yourself and then watching along to see how I work through it, to check if you're on the right track, if you remember all of the work that you've learned throughout the year, or if you may be missing something. And then of course you have the opportunity to correct yourself, to correct the answers and make sure that you don't repeat those mistakes in the future. Now before we hop into the question, I'd like to remind you that on what we call or normally refer to as the formula sheet, you're going to find a table of constants. We often look past this table of constants, but it contains a whole lot of very important and useful constants that you can use in your calculations. For example, we have over here the charge on an electron, the mass of an electron, the mass and the radius of Earth, quantities that may come up in different sections that you're not used to using. So please look at this table of constants, familiarize yourself with what is in this table so that you can use it where applicable. Then we have on your formula sheet the formulae that you can use in the section on Newton's laws. The first formula is used when we deal with Newton 1 and 2 problems, and it says that the net force is equal to the mass multiplied by the acceleration. Remember that force is always measured in newtons, mass is measured in kilograms, and acceleration is measured in meters per second squared. On the right hand side we have the formula that we use to calculate the weight, or we can refer to it as the gravitational force on an object, and that is equal to mg. This force is also measured in newtons, and g is of course the gravitational acceleration, or the acceleration due to gravity on Earth, given as 9.8 meters per second squared. Then we have the equation that allows us to calculate the gravitational force that two objects exert on each other. On the right hand side we have the formula that we use to calculate the maximum static friction. You may be familiar with this formula in this form that I'm writing out, but it means exactly the same thing. And lastly, we have the formula that we can use to calculate the kinetic friction, which is equal also to a coefficient, the coefficient of kinetic friction multiplied by the normal force. So for the normal force, you are more than welcome to make use of this symbol or this one over here, and for the weight you can use the symbol W or Fg. They refer to exactly the same thing. Let's now try this question. Question number 1.1 says, the graph below represents the data obtained in an experiment that aims to verify Newton's second law. Now we have a graph, and you may notice that on the x-axis we have the net force, while on the y-axis we have y. So we actually don't know what is being plotted on the y-axis, but we know it's on the y-axis. And if you remember correctly, you remember we always plot our independent variable on the x-axis and the dependent variable goes onto the y-axis. I like to remember this by thinking of a stick, a very thin stick, and a big heavy stone. And we say when the wind blows, the stick is going to fall down. Therefore, the independent variable goes onto the x-axis, while the dependent variable stands up on the y-axis. Let's now take a look at question 1.1.1. It says, state Newton's second law of motion in words. Newton's second law of motion says that when a resultant or net force acts on an object, the object will accelerate in the direction of the force at an acceleration directly proportional to the force and inversely proportional to the mass of the object. So normally we award 1 mark for the first part and 1 mark for the second part of the statement. It's often very difficult to remember statements as long as this one, and that is why it's important that you find links between the definitions or statements and the formulae. See, we remember Newton's second law using this formula. But we can manipulate this formula by dividing by the mass, and we then have that acceleration is equal to the net force divided by the mass. Based on this, we can see that acceleration is directly proportional to the net force, because as the net force increases, the acceleration is going to increase. But the acceleration is inversely proportional to the mass, because as the mass, which is in the denominator, increases, the acceleration is going to decrease. So try to find links between the formulae and the definitions, because this is going to help you to get your 2 marks. Sometimes we award 1 mark for one part and the second mark for the second part of the statement, but sometimes it's all or nothing. So it's best to learn all of these definitions word for word and to make sure you don't leave any part of the statement out. So now we go on to question 1.2.2, which says, write down the quantity represented by y with its correct units. So if we take a look at this graph, we see that we have an increasing straight line that passes through the origin. So on this graph, or displayed or represented by this graph, are 2 quantities, a relationship between 2 quantities that are directly proportional, because it cuts through the origin, and as the one value increases, the other one increases as well. So what increases when the net force increases? Well, since we are familiar with Newton's second law, we know that that is the acceleration. And we can therefore say that the answer to question 1.1.2 is acceleration. And what is acceleration measured in? It's measured in meters per second squared. You're going to get 1 mark for the word acceleration and 1 mark for the correct unit, but please make sure that you have a -2 on the seconds. We can go up to the graph and go and write down that instead of y, we actually have acceleration in meters per second squared. Now we can go on to question 1.1.3, which says, use the graph to calculate the mass of the trolley. So when they say use the graph, they normally mean don't make use of a formula from your formula sheet, but instead make use of things like the gradient of the graph, the y-intercept, or the x-intercept of the graph. Taking a look at this graph, we see that the x and y-intercept are both at the origin, so that's of no use to us, but we can definitely calculate the gradient of this graph. But what does this gradient represent? Well, in mathematics, we say that the gradient is equal to the change in the y values divided by the change in the x values. In this case, instead of having change in y over change in x, we see that on the y-axis, where we have the dependent variable, we have acceleration, and on the x-axis, where we have the independent variable, we have the net force. Acceleration divided by net force can be found, or we can sort of try and find a link between that and mass by taking a look at this formula. So if we take that formula and manipulate it, we have F net equals ma. Let's divide by acceleration, then we have mass is equal to F net divided by a. Taking a look at this, and that, we see that they are the reciprocals of each other. Therefore, the gradient in this case actually represents 1 over the mass. It is the reciprocal of the mass. So let's start off by finding the gradient, and then we will use the gradient in order to find the mass of this object. Acceleration, we're going to use 2 points first. So let's use these 2 points. You can use any 2 points on the graph. The coordinates of this point at the top is 4, x value first, 12, 4, and at the bottom through the origin we have 0, 0. So that is going to be 4 minus 0 over 12 minus 0. That gives us 4 over 12, which we can simplify to 1 over 3. That is what is represented by the gradient. But if we'd like to find the mass, we will have to find the reciprocal. So we say, therefore, the mass is equal to 1 over the gradient, which is equal to 3 over 2. Sorry, not 3 over 2, but 3 over 1. And that gives us a final answer of 3 kilograms. So the final answer is 3 kilograms. If you took this answer and rounded it off, you may have obtained something like 3,03 kilograms, and that's okay. But remember, we normally say that we round off right at the end of the problem. So this is the answer to question 1.1.3, which is out of 3 marks. So you're going to be awarded 1 mark for what you substitute at the top, your y values, your change in y, 1 mark for what you substitute at the bottom, or change in x values, and 1 mark for your final answer with the correct unit. If you don't include the correct unit, you're not going to get your marks. Now we move on to question 1.1.4, which says, determine the value of z. Z is a value of acceleration in meters per second squared. It is one of the values on our scale, and we can see that Z is the acceleration obtained when the net force is equal to 8. Now, in this problem, they do not say that we need to specifically make use of the graph, so you're welcome to make use of the gradient and to substitute into a mathematical formula, but I'm going to instead make use of a formula that you're very familiar with, which is F net equals to ma. We know that the net force for the Z value is 8, so in the place of the net force, I'm going to put 8. We just found out that the mass is 3, and we don't know the acceleration, which is the Z value. Dividing both sides by 3, we find that the acceleration is equal to 2,6, we round off 7 meters per second squared, and therefore the missing Z value is 2,67. You can of course include the meters per second squared, but Z is actually just a number on the y-axis, so if you did not include that, you will still get your marks. In this case, we'll award 1 mark for the formula, 1 mark for substituting, and 1 mark for your final answer, which is the value of Z. So grade 11s, this brings us to the end of this video. We're going to continue with question number 1 in the next video. So please make sure that you watch that video as well.